pounds at an angle of 35 degrees. Okay, so we have a stack shoe. One side is 35 degrees away, and then crane B is at a force of 750 pounds at an angle of 50 degrees to the right. Okay, so let's go ahead and draw this. So if I have my stack shoe, there's my stack shoe. Okay, and it says angle of 35 to the left. So if I go to the left of that, this would be a 35-degree angle. Back with me on that part? Yes?
Yes.
Okay, and then it says crane B is pulling at an angle of 50 degrees to the right. So we'll do 50 degrees to the right. So we have two vectors. One's at 35 degrees to the left, one's at 50 degrees to the right. Now, typically, okay, if I extend this, we would draw it on our coordinate plane. So I'm just going to extend it, draw it on our coordinate plane. Okay, so our 35-degree angle. If we're looking at the ground, okay, here's the ground, which is our x-axis. Okay, we need to decide how far is it from the ground. Like if the ground's here, how far is that angle? So 35 is actually how much from that side? How would I find that angle? That plus 30. What's this angle here? 90. Okay, so 90 plus 35 is 125. Okay, so we're going to use angle 125 when we put it into our component form. Okay, now my 50-degree angle, we'll say this is 125. My 50-degree angle is how far from the x-axis, from the ground here? 40 degrees. Okay, and 40 degrees. So we're going to use, instead of the 50, we're going to use 40 degrees because that's in relation to the ground. We're thinking application-wise here. So those are the two angles that we're going to use. Okay, so let's focus on that 35-degree angle, which is now 125. That's a force of 600. So we have 600 cosine 125 sine 125. I want you to see if you can write crane B's component form. See if you can do crane B. Okay, do you agree with me? Force is 750, right? Instead of that 50 degrees, we're using from the ground, which is that 40 degrees, so we put in 40. Issues, questions? Okay, so now we talked about yesterday, when we are doing resultant force, okay, this is where we add them together. So we add our cosines separately from our sines. You can just do it straight in your calculator.
So when you put it in the calculator, do you just put it all in and then?
So you do 600 cosine 125 plus 750 cosine 40, and that's your first.
So would you have to like actually physically, so like 600 cosine 125 parentheses plus parentheses 700?
I'll do it up here.
I was just so like they don't intermingle in ours. So I didn't know if it was different on yours.
What do you mean?
So like when I'm entering it in, whether I need to put each of the components in parentheses.
Yes, always put parentheses.
That's what I was assuming, but I just wanted to make sure.
That's exactly how I'd put it in, like that.
Okay.
And then your first one, ooh, Oh, I'm not in degree mode. Gosh darn it. I forgot that this thing changes every time I exit out. Okay, let's try that again. Okay, there we go. That looks a little bit better. 230 point, we'll say 39. So if you need to see that again, there it is. Okay, and then our second one would be 600 sine 125 plus. And the way that I kind of think about it is like when you're adding them, you're adding the cosines together and you're adding the sines together. Kind of a way to think about it. That one should be 973.58. So that is the component form for the resultant force on both. So both forces coming together, that's your resultant force, basically, is when you add them. Okay, and it asks us to find the magnitude and the direction angle. So we're doing magnitude and direction angle, which from here, this is stuff that we've been doing for a couple weeks now. You should be familiar with. Do you guys make sure I put this one in? All right, you should get 1,000.47. I'm sorry? Okay, so there's our magnitude. Okay, that's the length of your vector. And then for our angle, we do B over A. What quadrant are we in here? How do you know that we're in quadrant 1? Positive, positive. So when we do our angle, we don't need to add anything to it because we're in quadrant 1. When we do it, do we just do regular tangent or inverse tangent? Inverse tangent of our fraction. Do you want me to show you that one as well? Okay, right. So second tangent, and then I put in my fraction. Oh. Okay, 76.69. 76.69. Now, if we needed to add something, we would add it right now, but we don't need to because we're in quadrant 1. Okay, so if it asks for the component form, you would have left it up here. But it asks for the magnitude and the direction. So you need to do that direction angle as well. Okay, question for me?